This is 2010 FRQ number 3, still in the calculator section. All right, there are 700 people in line for a popular amusement park ride when the ride begins operating in the morning. So initially we start with 700. Okay, once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. So, okay, the graph above shows the rate at RT at which people arrive at the ride throughout the day. So this is RT, is people coming onto the ride, right? RT is coming onto the ride, coming to ride. But I process them. This is y equals 800. This is going off to the ride, right? They move on to the ride. Basically what this is saying is these are people coming to wait in line. These are people I'm getting off of the line, right? So as you can see, this is typical of an amusement park. You start with a lot more people than you can get them off, but at some point you kind of reach an equilibrium and you have less people in line than you can get off of the, you have less people in line and you actually have less of a wait as the day progresses, okay? How many people arrive at the ride between t equals 0 and t equals 3? Show the computation that leads to your answer. So again, this is a rate. If we want to look at between 0 to 3, I'm looking at all the people, all the folks in here. So what's a quick way of doing this? You decide. What I did was I made it into 2 trapezoids. So this is 1 trapezoid and this is the 2nd trapezoid. All right, so for part A, I say, okay, so the integral between 0 to 3 r of t dt, right? That's the total number of people getting onto, coming to the ride between 0 to 3. And since there's no function for r of t, the easiest way is to use geometry and figure this out. So I have 1/2. Here's my height of 2. And then base 1 is 1,000. Base 2 is 1,200. All right, 2nd trapezoid, 1/2. Height of 1. Base 1 of 1,200. Base 2 of 800. All right, so what do I get? Put these all in the calculator or calculate this out. I have a total of 3,200 people. All right. For part B, it says, is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 or t equals 3? Justify your answer. So the rate at which people coming onto the line is decreasing, right? But it's not asking if the rate is decreasing or increasing. It's asking is the number of people increasing or decreasing. So notice how between 2 to 3, your line is still above 800. You are still coming in, adding more numbers to the line than what you are taking off of the line. So the number of people are increasing. So how would you explain this? Let's see. Justify your answer. I would say R of t is above 800 and t is between 2 and 3. Oops, 2 and 3. Sorry about, let me rewrite this. Between 2 or 3 hours. 2, 3, right? So the number of people waiting on the ride is still increasing. Sorry, number of people waiting is still increasing. If my number is below the 800, then my numbers are decreasing. Okay. All right, part C. At what time t is the line for the ride the longest? How many people are in line at that time? Justify your answer. Well, what time is the longest? I would say at t equals 3 because that's the most above how much I can take off of the ride, right? So at t equals 3, this is the most area above the line y equals 800, right? So that it has it has the most people waiting in line, right? So what is how many people are in line? So number of people is equal to, first we start with initial 700 people, right? Plus we're gonna add in these folks coming in r of t dt, but we're gonna take away all this because these are the folks I can get off and go onto the right. So take 800 times 3, right? So this is 700 plus what we got from part A, 3,200 minus 2,400. I have 1,500 people at t equals 3 hours, right? So that is the most people I have in here, okay? All right, last, write but do not solve an equation involving integral expression of r whose solution gives the earliest time t at where there's no longer a line for the ride. That means the number of people and the number of getting off should be exactly the same. So let's see, we want 0, right? When will it reach 0? Well, we start with 700 people. We're going to add, well, people are coming onto the ride, putting 0 to some time that I don't know of, right? This is adding people to the line, but I'm also taking away people from the line, right? So as soon as the start number plus adding more minus how much I'm taking, how many people I'm taking out, all equals 0, that means there's no longer a line for the ride.